So today we're talking about domain and range. So this is the next lesson in this unit. You guys are going to be able to identify functions um, and also state domains and ranges of these respective functions or relations. So let's get a little bit of vocabulary out the way. A relation is a set of ordered pairs. Okay, a set of ordered pairs. Now, when I say set, you should think set builder notation in the sense that we should think what type of brackets, the curly brackets, okay? So when a relation is a set of ordered pairs, then that means we're talking about like 1, 1, 2, 2, 3, 4, for example. This is an example of a relation. It's just a set of ordered pairs, okay? Now what makes that relation a function is if it has no two ordered pairs that have the same x value. Okay? So when you look at this example that I gave in the purple, 1, 1, 2, 2, and 3, 4, this would be an example of a function because none of the x values repeat themselves. Okay? So then that's how you can tell the difference between something that is a function versus something that is a relation. Okay? So today when we're doing domain and range, I'm also going to ask is this a function? And you'll be able to look and say, okay, do the x values repeat themselves? If they do, then it's not a function. If they don't, then it is a function. Okay? And just to make sure that everyone is clear, x is your independent variable and y is your dependent variable. Okay? So when you're thinking about domain and ranges, domain is your x and range is your y. Okay? And this is how we're going to label your foldable. Okay? Now, you want to make sure that you put the word graph beside the ones that actually have the graph, ordered pairs beside the one that actually has ordered pairs, table, and diagram or map around the respective ones. So, if you look at your foldable where the graph of like the parabola is in your top left, then that's how it should be labeled, okay? So then this one should be graph. The ones that actually have the two examples of the ordered pairs should be labeled ordered pairs, and so on and so forth. So go ahead and get this labeled. So with each of these, we're going to determine if they're functions, and we're also going to state the domain and range. Okay? So let's look at the first one. Let's look at the graph. Okay? In this particular example, you're given two graphs, and we're going to determine if it is indeed a function or if it's not a function, and we're also going to state the domain and range. Okay? When you're given a graph, one way to determine if it is a function is by the vertical line test. You guys, have you ever heard that before? Maybe back in algebra 2. The vertical line test basically says that if a vertical line passes through the graph more than once, it is not a function. Okay? A graph is always a relation, but not every graph is a function. Okay? So if I look at this graph over here on the left, is that a function? No, it is not a function. Okay? Because if you do any vertical line, it's going to hit the graph in two places, as you can see here. So that's what makes it not a function. But what about the one on the right? Yes, because no matter where your vertical lines are drawn, it's only going to hit the graph in one place. So this is an example of a function. Everybody got that? Now let's talk about the domain and range of each of these functions. I'm going to go ahead and erase these drawings that I did, so that way we can see, I can see the graph a little bit better. Now domain are your x values. Reading from left to right, where is the function defined? Okay? How far left does this graph go? To -1 on your x value, okay? That point right there. Okay, vertex. That's how far left it goes. So it starts from -1 and it goes all the way to what? To make this easier, let's just draw arrows on this. What do the arrows mean? To infinity. So if I wanted to write the domain in interval notation, this would be pretty simple, right? The furthest left it goes is -1, like you said, and then the furthest right it goes is to infinity. What am I missing if I wrote it in interval notation? Where do I need parentheses? After the infinity, what do I need around the -1? A bracket. And remember, if you use the bracket, if it is defined, use parentheses. It's not defined. Infinities always have a parenthesis. But in this case, since it actually is a closed circle at that vertex, it is right. Okay? Range, you look at your y's now. How low does this graph go? How high does it go? From bottom to top. What do you think is going to happen after this endpoint on this graph? It's going to get bigger and bigger and bigger, expanding all the way. What's the lowest that it goes? All the way down. What's all the way down? Which one? Negative infinity. And then it goes all the way to what? What goes around both of these? And there we go. We have our domain and our range in interval notation. Y'all remember this? Maybe? Long time ago. Now, will I always want you to write your domain and your range in interval notation? No. Okay? But we have practice going interval and into set notation. Okay, so sometimes I might ask you to write in set, sometimes I might ask you to write in interval, so I need to make sure you guys know how to do both. How do you write negative infinity to infinity in set notation? Anybody want to take a guess? Could do that. Only issue is with set notation, you never see infinity. Have you seen any infinities in set notation? Okay. What does that mean? Negative infinity to infinity. What does that mean? Huh? Any number. Any what type of number? Any real numbers. Right? Don't we always put that at the end of like a majority of our? You just won't put anything before it. So write negative infinity to infinity in set notation. Since this is the range, we're going to use what variable? Y. So the set of y values such that y is an element of all real numbers. That's how you write negative infinity to infinity in set notation. Okay? Because that's it. We're including all the real numbers. No restrictions. All of them. Good? Okay. Let's look at the second one. Let's look at the domain. And to make it easier on us, we're going to go ahead and include these little arrows. What's the domain? How far left does it go? Negative infinity. And how far right does it go? Positive infinity. So negative infinity to infinity, just like before. Or I can write it in set notation, the set of x values such that x is an element of all real numbers. Same thing as saying negative infinity to infinity. But what about the range? What's the lowest it goes? Which one? Negative infinity all the way to what? Positive 1. So basically, negative infinity to positive 1. That's how I would write it in interval notation. Is 1 included? But how would I write it in set notation? How do I represent that in set notation? Equal to. So we got less than or equal to 1, and is this y or x? Y. So that's how I would write the orange in set notation or inequality notation. Now it's got to include all the goods. The set of y values such that y is less than 1, and y is an element of what types of numbers? All real numbers. This would be my range. Again, will I expect you to write both? Let's see, let's do your homework. What's next? Let's specify, okay? So since your homework doesn't specify, I'll let you choose whichever one you feel more comfortable with. But remember, you cannot use interval notation every time. Sometimes you're going to have to use set notation, okay? Set notation we use all the time. Let's look at when you're given some ordered pairs. If the x values of the ordered pairs are repeated, it is not a function. So now I'm looking at a set of ordered pairs, just like I was explaining before. If there is an x value and a y value for each ordered pair, then it's a relation. Okay? So let's take a look. Do any of these x values repeat in the first one? No. So because they don't repeat, is it a function or is it not a function? It is. So yes, it is a function. What about the example on the right? No. The 3 repeats. Okay? But just because it's not a function doesn't mean we can't find the domain and range. We're still going to find the domain and range. Okay? And to me, you always want ordered pairs because they're the easiest to do domains and ranges. Domain is what? Which value? And range is? And since they're ordered pairs, all you can do to write this is use set notation. That's the only way you can do domain and range with ordered pairs is set notation. And all you do is list them. The smallest to largest. That's it. Okay? What's the smallest x value out of this set? What's the next smallest? What's the next smallest? Boom, we're done. That's it. List them. What about the range? -6. If there are multiple y values, you only got to write it once. So we don't got to do -6, then -6, and then the next one. Just -6 one time. What's the other one? We're done. Do the second one. Give me my domain and range. Remember, when they're ordered pairs, domain and range can only be written in what notation? In sets. I'm trying to come out here and do interval. No, this work that way. All right. So what's the domain for the one on the right? Alexa, what you say? 3 and 4. And what about the range? What about the range? Calista, what you get? Awesome. How are we doing so far? So we talked about how to find domain and range from a graph. Remember, you go left to right, bottom to top to get domain and range. With the ordered pairs, your x's is your domain, your range is your y. Table is about as easy as ordered pairs. This is another representation of your points. Okay? So again, if the x values are repeated, it's not a function. Okay? A table will always be a relation. Every x should have a corresponding y. Okay? Is the one on the left a function? No. Don't we have a repeating x value? What about the one on the right? Yes. None of the x's repeat. And just like the ordered pairs, the domains and ranges are in sets, and you just list them. Okay? So go ahead and give me my domain and ranges for my tables. Aurora, what you give for your domain for the first one? The one on the left. Very good. With the curly brackets, right? Awesome. Okay. And then what about the range? Paige, what you get? A lot. Paige, what you get?
Curly brackets, -6, 1, 2, 3, 4.
Awesome. Okay. The domain, Erica. The second one. No. Okay.
-4,
Mhm.
0.
Mhm. Very good. And the range. The line.
-2, 3, 5.
Good stuff. Easy peasy. There we go. All right. This right here is an example. The next one is an example of a mapping diagram. Now, of course, as you notice, there are no circles around your numbers. That's because it was kind of difficult trying to put the circles in. So go ahead and circle those groups of numbers. Okay. And once you have your circles in there, you now have a completed mapping diagram. Okay. And all a mapping diagram is basically maps your input to one output. if it is a function. So basically the column on your left are your x values. The column on your right is your y values. And the arrows basically connect the ordered pairs together. So on the one on the left is basically you have 4, -7, 3, -7, -2, -7, and then 10 and 11. Like those are your ordered pairs. It's just represented in a different way. Okay? It's represented in a different way. But the same rules apply. Do I have any repeating x values? Like, okay. So since you don't have any repeating x values, is it a function? Yes. What about the one on the right? Look at this one. You see that 3? You see how it has 2 y values? So it's basically saying 3, -1, and then 3, 2. So that would be an example of repeating. So this one would not be a function. Okay? And even though there are some numbers that don't have arrows drawn to them, that's okay. It's still a function on the one on the left as long as your x values have a corresponding y value. Okay? It's okay to have empty y's. You can't have any empty x's though. Okay? So the domain for this one, -2, 3, 4, and 10. The range though, you gotta be. Oh, I don't know. It should be a curly bracket. Thank you. I didn't even realize it. Ooh. Now the range though, you only include the y values that are included. You don't list all of them, only the ones that the arrows are pointing to. So that will be what? -7. It's probably a bad drawing, but this arrow too is actually going to -7. And then the other one would be 11. Okay? What about over here? What's the domain for this one? 3 and 4. Not 1, 3, 4, and 9 because the 1 and the 9 are not involved. What's your range? Yep, -5, -1 is the terrible curly bracket. And that's how you find the domain and range through these different representations of functions or relations. Okay? Do you have any questions? All right. Go ahead and get this glued into your note page.